welcome you all in the 23rd lecture of Electronics Measurement and Instrumentation. In this lecture, I will discuss about the transducers. So, transducers are the electronic equipment, or it is a type of system or the equipment which transfers one form of energy into another form. So, in this lecture, I will discuss the basics of the transducers, the need of the transducers, why we do need transducers, what are the different parts of the transducers, and what are the different factors that we should consider while selecting a transducers. What are the different application of a transducers, then classification of transducers, characteristic of transducers, and the type of errors introduced in the transducers. And I will discuss few example of the transducers. So, what is transducer? Transducer is a device which converts one form of energy into another form. For example, we can take example of microphone. Microphone we are using in our laptop or in our mobile. So, the function of microphone is to convert sound signal into electrical signal. When the microphone is generally made up of a diaphragm, and when we speak, our sound signal impinges on the diaphragm, and diaphragm is a flexible material. So, when it impinges on the diaphragm vibrates, and because of the pressure of the vibration in the pressure of the microphone, the electrical signal is generated, and these electrical signal may be processed by using filters or by using amplifiers, and then fed to the then transmitted via the mobile and other places. Similarly, loudspeaker is one other type of transducer that may be known as inverse transducer, which converts electrical energy into sound signal. Similarly, we have many transducers at our body. For example, we have ear. So, what is the function of ear? The function of ear is to convert the sound signal into electrical impulses that is forwarded to our mind, and so our mind can sense what the person is speaking. So, and there are two basic parts in a transducer. One is sensor and other is actuator. So, sensor basically sense the signal, any form of physical phenomena, and it converts it into electrical signal. So, sensors have basically respond to the physical phenomena or the environment in which it placed, and the quantity which we want to measure using those sensors. So, and it converts it into electrical signal. Then that electrical signal has to be reproduced on any type of instrument. Suppose we want to convert temperature into electrical signal, then that temperature signal is converted into electrical signal, and that electrical signal we need to display. So, for the displaying purpose, again this electrical signal has to converted into the displacement. So, that is done by voltmeter or ammeter, and we can calibrate the voltmeter in terms of temperature, and it will give the value of temperature. So, that electrical signal which is converted from electrical signal to another energy, that is known as actuators. So, we can see that the lamps also convert the electricity into light. Similarly, our CRO, the output of CRO, again CRO converts the electrical signal into light signals. So, these are known as actuators. So, every transducer has two parts, sensor and actuators. Then why do we need transducer? What is the need of transducer? So, to determine the exact magnitude of physical force such as temperature, pressure, displacement and other quantity, we need transducers. So, any physical force that is converted into electrical signal, and it is very easy to use the equipment that can measure the electrical quantities like the change in voltage, change in resistance and change in power. So, what is the advantage of converting physical quantity into electrical quantity? So, first thing that we can transmit, we can process the electrical signal, we can segregate the desired frequency component from the undesired frequency component, and we can process it, we can amplify the signal, we can attenuate the signal, and we can transmit the signal, we can modulate the signal and transmit it, and we can process it for the measurement. Then the process less friction error, because there is no movable component in the electrical signal. So, the process less friction error is there. Then for the electrical signal we need small power, because generally the signal which is converted into electrical signal that has a value of in microvolt. So, if we amplify it, then again it has less than the 5 volt. So, we can easily, small power is needed, and so we can easily control the electrical systems. Then amplification and attenuation can be done on the electrical signal. If the signal amplitude is more, we can attenuate the signal, and if the signal amplitude is less, we can amplify the signal to operate the desired output equipment. Then next is the measuring instrument needs used for measuring the electrical signal is very compact and accurate. So, these are the advantages of using a transducer that converts a physical quantity into electrical signal. Then part of transducer. So, there are two parts of transducer, one is sensing element, other is transduction element or the actuators. This is element. So, sensing element basically it senses the electrical quantity and convert it into response, like there is a Burden tube. So, Burden tube senses the pressure and it converts it into displacement. Then we can use LVDT, which converts the displacement into electrical signal. So, there are two things, one is the sensing element and other is the transduction element. So, transduction elements can convert the sensing element into electrical signal. These are the block diagram of transducer system. So, here we have used a load cell as a transducer. So, the force signal, force or pressure is applied on the load cells. As we know that if we want to measure a loaded truck, then we are using strain gauges with the load cell. So, it can measure the weight in tons. So, suppose the force or any pressure is applied on the load cell, then load cell convert it into change in resistance. We can use these load cells in Wheatstone bridge as one part. So, at condition where there is first time there the load cells basically converts the change in resistance. So, at balance condition, suppose we are using it in the Wheatstone bridge and we make a balance condition, then we apply the force on the load cell, then there is a change in resistance, and because of the change in resistance there is change in the value of the output of the bridge circuit. So, the detector circuit of the bridge circuit will detect the change, and that signal is fed to the amplifier circuit, because its value change in resistance is again converted into change in voltage, and it may possible that the change in voltage may be of a microvolt or millivolt. So, it should be converted into volt. So, it is fed to the amplifier circuit to amplify the signal. So, amplifier circuit amplifies this circuit, then it is fed to the data acquisition system. So, data acquisition system may consist of filters, may consist of low noise amplifier. So, it can extract the original signal from the noise signal, because maybe it may possible ki in load cell there may be a noise signal introduced. So, we have to extract our signal from the noise signal. So, that noise so that all amplified signal is fed to the data acquisition system. So, if whatever the device that needs, suppose frequency extraction is required, then we use filter circuit, and then if the attenuator is required, so we need attenuator circuit, or amplifier, again amplification is required. So, whatever requirement, or suppose we want to convert the analog output into digital form, then analog to digital converter is required. So, all this come under the data acquisition system. So, data acquisition system, suppose we want to store the data in a computer. So, on a computer system, so we have to convert the amplified signal into digital signal, and then that digital signal may be recorded on the computer system. So, this is the complete block diagram of the transducer system. Then factors to be considered while selecting the transducer. Whenever we go for a particular transducer, that which particular transducer we have to select. So, we need a transducer that should have high sensitivity to the desired signal and insensitive to the unwanted signal. Means it can pick only the desired signal and it can remove the unwanted signal. So, first thing is that it should have high sensitivity. Sensitivity means the change in output by change in input. So, it can sense a very small change in input. So, the transducer's first priority is that it should have high sensitivity to desired signal and insensitive to the unwanted signal. Then it should be able to work in corrosive environment. Then it should have overload protection. Means suppose we want to measure we are having a temperature sensor, and suppose the range of temperature sensor is from 0 to 100 degrees centigrade, and suppose we are measuring 700 degrees centigrade, then it will not measure the 700 degree centigrade, but it may distort that particular temperature sensor device. So, there should be a overload protection circuit, so that if there is overload, it should protect the transducer from that overloading. Then it should have high input impedance and low output impedance. So, high input impedance we need for any voltage amplifier or any device that should not load the other device, because if we connect that transducer to any device and if it has low input impedance, so it will draw more current from the previous circuit. So, more current means it is having a loading effect on the previous circuit. Similarly, if it has high output impedance, so again we know that V is equal to IR. So, if its resistance is high at the output, then it will provide low current to the next circuit. So, any component, any transducer or any electrical matching equipment should have high input impedance and low output impedance, so that it can measure so that it will not load on the previous circuit. Then we have to see which type of signal we want to measure, which physical quantity. Suppose we want to measure intensity, displacement, heat, speed. So, that particular transducer we have to use. Suppose for heat measurement we have to use the temperature transducer. For the displacement we have to use the transducer that can measure the displacement. Similarly, pressure and light, etc. Then we prefer the transducer which do not require frequent calibration, because it is not possible to use to use that particular transducer for which have frequent calibrations, because we have to remove the transducer from that place and then we have to calibrate it and again fit it at that place. So, we do not require a transducer that need a frequent calibration. So, the deformation should not be there. If pressure is applied and there is a transducer which converts pressure into electrical signal, and then when we have applied a pressure and suppose that particular transducer deformed, then it is very difficult to measure it, to calibrate it again and again. Then range of transducer. Range is also important factor, that the transducer that we are using, it should be the range of, like we want to use a pressure we want to measure like 0 to 10 Newton, and suppose the pressure transducer that we are using, it has a limit of only 0 to 1 Newton. So, we can't measure that this 0 to 10 Newton pressure by that particular transducer. Similarly, temperature range, if temperature transducers are used, then the range should be taken care of. So, range of transducer is also a very important factor. Then specification of transducer, like say shape, package, where we are going to place that particular transducer. Suppose there is a compact device in which we have to place a transducer, then the size of transducer and the shape of transducer and the weight of transducer has important factor on that. Then operating principle, whether we want to convert that particular physical quantity into change in resistance or change in inductance, capacitance or other. So, what are the operating principle that is also required. Then sensitivity, sensitivity is enough sensitivity is required so that it can detect the signal. Suppose there is a system which has very small change in temperature, and if we are using an temperature detector which cannot which are not able to detect the small change in signal, then it is not suitable for that particular operation. So, sensitivity is also an important parameter. Then operating range, range is also if whatever range we are going to use, that particular operating range should be required. Accuracy, accuracy means the measured value, how close is the true value. So, high degree of accuracy is required, that the transducer that is converting the physical energy into electrical energy, then it should be very accurate, the conversion should be very linear conversion should be there, and it should be accurate, that the conversion when converted into electrical form, then it should be accurate to the value. Then repeatability means every time it should show the same result. There is no deviation in the result when we measure the same quantity for many times. So, repeatability will be also considered. Then environment compatibility, it should be assured that the transducer which we have selected under that specific environment, that it should maintain the input output relation. Means if there is any environmental issues, means there is moisture, there is any other issues, then the output input relation should not be affected by that environment. Then insensitive to unwanted signal, the transducer should be minimally sensitive to the unwanted signal and highly sensitive to the desired signal. Then usage and ruggedness, the ruggedness both of mechanical and electrical intensities of transducer versus size, weight must be considered while selecting the transducer. Then electrical aspect, then the length and the type of cable required, so that signal to noise ratio should be less. So, whether we can use the connecting wire of high length or low length, or which type of cable we can use, which type of wire we can use, that is also very important parameter while selecting the transducer. Suppose we want to measure any temperature of any furnace, then and suppose the company has many furnaces, because we are having a industry in which many furnaces are there, and we want to measure and control the temperature of different furnaces. So, it is it should not be possible for the industry that he has to the industry supply one person for each furnace. So, the temperature detector circuits are temperature detector transducers are placed in that furnaces, and one person can control by locating at central place, can control the temperature or can find out the reading of all the transducers by sitting at one place. So, electrical length of cable required is also very important part, that it should not introduce the noise while transmitting the signal, because the converted electrical signal has very less amplitude, and if there is noise is introduced, it is very difficult to remove that noise. So, and if there is output of this is passed through the amplifier, so amplifier should be low noise amplifier, and so it should pass through that amplifier. Then cross sensitivity, when mechanical quantities are measured, then it may be possible that our transducer is placed at one plane, and the equipment whose mechanical quantity we want to measure that is placed at another place, and suppose there is a vibration in that place. So, the transducer should not be affected by that vibration. So, transducer should maintain the expected input output relationship as described by the transfer function. So, it should not be affected by the vibration of the other surface. Then transit and frequency response. The transducer should meet the desired time domain specification, like if there is peak overshoots, rise time, settling time and a small dynamic error. It should ideally we have a flat frequency response over all the range. Whatever the range for whatever the range of that particular physical quantity we want to measure, for that particular range it should have flat frequency response curve. Then stability and reliability. Transducers should exhibit a high degree of stability and to that particular operative range, and it should have storage for all the storage time, it should have the same response and same stability, and finally it should be economical. Then classification of transducers. Transducers are classified based on whether it is using power supply or not, whether it is directly converting it into electrical signal or not, whether it is producing a digital output or analog output. So, this is the classification of transducer. Then first classification is that active and passive. We can classify whether the transducer is using power supply or not. So, if a transducer does not require any power supply, then it is active type of transducer. So, active type of transducer we can take example that piezoelectric crystal. So, in piezoelectric crystal when power is applied, then if the pressure is applied in piezoelectric crystal, then that power that pressure is converted into change in voltage. So, that change in voltage, because this piezoelectric crystal does not require any input voltage, any auxiliary source, but it the piezoelectric crystal already producing a change in voltage. So, it is the active type of filter, active type of transducer. Then there is another passive type. Then suppose the LVDT is there, when the displacement is applied on the LVDT, then that displacement is converted into electrical signal, but this LVDT needs here two coils are excited by the electrical signal, and under two coils, the primary and secondary winding, the LVDT one core is moving, and so it needs electrical input. So, passive transducer require the electrical input and the active transducer does not require the electrical signal. Similarly, primary secondary transducers. Primary transducers are those transducers, suppose there is a pressure, then pressure is to be measured and we have LVDT to measure the pressure. Then that pressure is converted by the burden tube in the displacement, and that displacement is measured by the LVDT. So, that burden tube is primary equipment, primary transducer, and the LVDT at this time is the secondary transducer. Similarly, analog and digital, if any transducer that converts the input into analog electrical signal, then it is analog type, and when if suppose we want to convert it into digital form, then we have to use a analog to digital converter. So, when physical quantity that is converted into electrical quantity and it is in the form of analog signal, then it is analog type of transducer, and otherwise if it produces a digital signal, then it is digital type of transducer. Then based on transaction, means resistive, capacitive and inductive. There are three type of transactions are there. First, suppose if there is a change in temperature, then if the change in temperature is converted into change in resistance, then it is resistive type of transaction. If suppose there is a microphone or we are using the mobile screen, so when we push the mobile screen or when our the sound signal impinges on the microphone, then there is variation in capacitor, means one plate of the capacitor is fixed and the other plate is movable, and this movement is depends upon the input signal. So, that type of conversion, when the physical quantity is converted into a change in capacitance, then it is capacitive type of transduction, and the transducer is known as capacitive type. Similarly, if there is a change in inductance, then it is known as inductive type transducers. Similarly, there is, we can classify as transducer and inverse transducer. So, transducers are basically when it converts mechanical energy into electrical energy, then that is the transducer, and inverse transducer that converts electrical energy into physical quantity, like tube light, it converts electrical energy into physical quantity, the loudspeaker which converts electrical energy into sound signal. So, we have discussed about transducer, the classification of transducer, how do we select the transducer, what are the requirement of the transducer. So, we have considered all these, we have discussed all these. Thank you all.